In this video, we'll talk about absolute value and adding real numbers, which is lesson 5 in your book, and we're also going to talk about subtracting real numbers, which is lesson 6. Absolute value just means the distance from the number to 0 on the number line. So, say you have a number line like this. You have 0 right here. And let's see, we've got 5. Okay, so the distance from 0 to 5 on the number line is 5. So the absolute value of 5 is 5. However, if we have negative 5 down here, the distance from negative 5 to 0 on the number line is 5. So the absolute value of a negative number is just the positive distance from 0 to that number on the number line. Right there we've got negative, those bars stand for absolute value, and we need to know how far away from 0 on the number line is negative 4. Well, we go from negative 4, negative 3, negative 2, negative 1, 0, so we know the absolute value of negative 4 is positive 4. The distance from positive 4 to 0 on the number line, the absolute value of 4 is again positive 4. The distance from 0 to 0 on the number line would be 0. Now here we've got 1 minus 3/4, and it's inside the absolute value bars. Those absolute value bars work as grouping symbols, so they're sort of like parentheses. You have to figure out what's inside of them before you can actually find the distance from 0. So we know that 1 minus 3/4 is 1/4. So we're looking for the absolute value of 1/4, or how far away is 1/4 from 0. And so we know that 1/4 is 1/4 a unit away from 0. Now here we've got a negative sign outside the absolute value bars. Again, those absolute value bars act as parentheses or grouping symbols. So just like order of operations, we do the parentheses or the absolute value bars first, and then we apply the negative. So we've got 11 minus 2, which is 9. So we have 9 inside our absolute value bars. Now this is the negative distance from 9 to 0 on the number line. So it's negative, and then the absolute value of 9 is 9. Now let's look at some real number addition. When we're adding real numbers, we want to look at whether they're positive or negative. Now, when we are adding a negative number, it's really the same as subtracting a number. So 4 plus negative 3 can be rewritten as 4 minus 3, because plus a negative is really subtraction, and 4 minus 3 is 1. Now you find the same thing again if you use a number line. So the number line, call that 4, 3, 2, 1, 0. We always start at 0, and we have a positive 4, so we're going to go to positive 4. Now we're adding negative 3. That means we are going to the left 3 units, 1, 2, 3, which gets us 1. So when you're adding a negative, it's the same thing as subtracting. Okay, now the next one says negative 2 plus negative 6. So we know in the beginning we're going to have a negative 2. We are adding a negative, which means we are subtracting. So this tells us to go 2 to the left on the number line, and then this tells us to go to the left 6 more. So negative 2 minus 6, we're working on a number line. Here's my negative 2, negative 3, negative 4, negative 5. All right, so negative 2, and then I want to go to the left 6 more. So negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. Now when you have a negative plus a negative, your answer will always be a negative, because you're going to the left and then going to the left some more. You're always going to end up with something that's to the left of 0, and those numbers are all negative. Here we've got negative 7 plus 7. So that means, in a number line sense, that we're starting out 7 to the left of 0, negative 7. And we want to go, positive is to the right, 7 units. So -7, -6, -5, -4, -3, -2, -1, 0, -7, and then to the right 7 or +7 is 0. All right, let's look here. It says the sum of two positive numbers is always positive, and we need to know, is that true or false? So, is there a counterexample that we can do? Are there any two numbers that we can add, positive numbers that we can add, that will give us a number that's not positive? Certainly not. No matter what you add, you're always going to get a positive number. So in this case, that's true. The sum of two negative numbers is always negative. Again, that's true. And on the last page I said, if you go to the left and then you go to the left some more, you're going to end up with an answer that's somewhere on the left. And all those numbers to the left is 0 or negative. Here, the sum of a positive and a negative number is always negative. Well, remember on that last page, if we had 4 plus -3, and we ended up with a positive 1, this is a positive and a negative number, and we're adding them and getting a positive 1. So that must be false, because we can find a counterexample for that. Anytime your positive number has a bigger absolute value than your negative number, you're going to get a positive answer. All right, so these are the rules for adding real numbers. Whenever you're adding two real numbers and one of them's positive and one of them's negative, the number with the highest absolute value wins the sign. For example, -12 plus 21. The absolute value of -12 is 12. The absolute value of 21 is 21. So since 21's absolute value is higher, we're going to have a positive answer. -12 plus 21 gets us positive 9. Right here, 3.2 plus -5.1. Absolute value of this is 3.2. Absolute value of this is 5.1. So our answer is going to be negative. And -5.1 and 3.2 make 1.9, or -1.9. Here we've got -19 and -8. So we're adding two negative numbers, so our answer will definitely be negative. -19 plus -8 is -7. Lastly, we've got -3/5 plus -1/5. They're both negative, so we're definitely going to have a negative answer. And they have common denominators, so we simply combine the top two numbers. -3 plus -1 is -4. And then our denominator stays the same. All right, so we need to know if these are true or false, and if they are false, we want to give a counter example. So, first of all, the set of integers is closed under addition. Basically, that means if you add two integers, you will always get some other integer. Well, what does it take to not be an integer? In order for a number to not be an integer, it has to be a decimal, a fraction that's not over 1, because any whole numbers or opposites work. So there's no numbers in the set of integers that we can add and get not an integer. So this is true. The set of real numbers is closed under addition, meaning all real numbers, when you add them, will produce some other real number. Well, I'm sure you guys have been adding for quite some time, and anytime you add, you've probably never gotten an imaginary number, because you have to have an imaginary number to get one in your answer. So the set of real numbers is also closed under addition. That's true. All right, last question for this lesson. On the first down, the Rams lost 4 yards. They gained 7 yards on the second down. How many yards were lost or gained? Right, so the first part says the Rams lost 4 yards. Now, That makes me think that that's a bad thing. So they have negative 4 yards to start with. Then it says they gain 7. Well, gaining is positive, so we want to add 7 yards on the second down. Now we need to know how many yards were lost or gained, so we'll simplify. Negative 4 plus 7. Notice 7 has the bigger absolute value, so our answer is going to be positive. Negative 4 plus 7 is positive 3 yards. All right, now let's move on to lesson 6, which is subtracting real numbers. Very similar to adding them. Opposite numbers, two numbers with the same absolute value but different signs are opposites, and they're also called the additive inverse. The sum of a number and its opposite will always be 0. Remember in that last lesson we did negative 7 and positive 7. Those are opposites or additive inverses, and their sum was 0. Here's our inverse property of addition. This is how we find our additive inverse. For every real number, a, which just means some real number, that number plus the negative of that number is the same as the negative of the number plus the number. And when you add those two, you'll always get 0. For example, 5 plus negative 5 will equal 0. 10 plus negative 10 will equal 0. That's the additive inverse. If you want to find the additive inverse of a number, all you have to do is change the sign. So if I want to find, let's see, if I have negative 1/2 and I want to find its additive inverse, all I have to do is change this sign to positive. When I add those two numbers, negative 1/2 and positive 1/2, I'll get 0. To subtract a number, add its inverse, then follow the rules for adding. So basically when we're subtracting, we're actually adding the inverse, and then we're just adding like we did in the last lesson. All right, here we've got some subtraction problems. Negative 12 minus 21. Notice here and here are absolute values. This is negative, so our answer is going to be negative. Now, to add a negative, to subtract, we simply add the inverse. So we can rewrite A here as negative 12 plus the inverse of 21, and the inverse of 21 is negative 21. Negative 12 plus negative 21 gets us negative 33. All right, here we've got negative 19 minus negative 8. So we're subtracting negative 8, which is the same thing as adding its inverse. So we can rewrite this as negative 19 plus the inverse of negative 8 is positive 8. Now 19 is bigger, so our answer is going to be negative. Negative 19 plus 8 is negative 11. Down here, we're subtracting negative 5.1. We can rewrite that as 3.2 plus the inverse of negative 5.1 is positive 5.1. Here we're adding a positive, and we get a positive 8.3. All right, and this last one, we've got negative 3/5 minus negative 1/5, which we can write as plus the inverse of negative 1/5, which is positive 1/5. Negative 3/5 plus 1/5, they have a common denominator. Negative 3 plus 1 is negative 2/5. That's how we subtract by adding the inverse. Now we want to look at closure. We want to determine if these statements are true or false. The set of integers is closed under subtraction. Are there any integers that we can subtract and not get another integer? Certainly not. So that is true. And finally, the set of real numbers is closed under subtraction. Can we subtract two real numbers, numbers we know how to work with, and get some number that's imaginary? Definitely not. So that is also true. And that is it for lesson 6.